Greetings! For this energy and transformation semester, we developed a horizontal water rocket. Our goal was to understand how the water inside a pressurized horizontal water rocket influences the distance it travels in a controlled setup. So to investigate that, we designed and tested a functioning prototype that helped us apply the second and third law of Newton.
The research question that we worked on was how does the volume of water inside of a pressurized rocket affect the distance it travels in a horizontal system? To answer that, we kept the same amount of air inside the bottle and only changed the water volume from 100 to 800 millimeters in increments of 100. That way we could isolate how water alone impacted the motion.
For our prototype, we use a 1 liter plastic bottle as a rocket body like this one, and a balloon for air containment and pressure also, a funnel for pouring the water into the bottle, and a Lego base wheel structure to guide the rocket straight. The launch system was pretty simple but effective. Also, we used an air pump like this one to inflate the balloon inside the bottle and seal the system. And then we release it for a launch, and the balloon's expansion forces the water out, pushing the rocket forward.
In physics terms, this works thanks to Newton's third law. When the water is expelled in one direction, the rocket is pushed in the opposite one. And the amount of thrust generated depends on how much water is expelled, how fast, and for how long. But the rocket also gains mass when we add more water. So Newton's second law comes into play, where more mass makes it harder to accelerate. Each trial was launched with 10 pumps of air, and the only thing we changed was the volume of water. We used a flexometer to measure how far the rocket traveled, and every launch was repeated and the average distance was recorded in a spreadsheet.
The results were very interesting. At first, increasing the water volume improved also the performance, but after 450 milliliters, the rocket started going shorter distances. That was because while more water creates more thrust, it also increases the rocket's total weight, which slows it down. And if the bottle is too full, there is not enough air left to push the water out properly.
Here is our graph. As you can see, the curve rises until 450 millimeters, then it starts to drop. This confirmed our hypothesis. There is an optimal point where thrust and mass are balanced, and below that there is not enough reaction mass. Above it, the rocket becomes too heavy and inefficient to be pushed.
And this isn't just what we observed. It matches what's described in reliable sources like NASA's educational material and other experiments, which show that rockets perform best when water fills about 40 and 50% of the bottle. This experiment let us test scientific theory in a simple but effective way. We use real physical laws to predict what will happen, and the results support them. We apply concepts like thrust, acceleration, mass, energy, and pressure in a controlled system. We built our results.
This also taught us to pay attention very much on our experimental design by keeping always our air pressure constant and only focusing on the water volume. We were able to draw accurate conclusions. And also we repeated trials, controlled variables, and analyzed our data carefully.
Now that we have finished the project, what could be done to improve it? Well, there were some inconsistencies caused by the friction, for example, or the experiment tools, which were made of recycled materials. The best way to improve this experiment will be to get better equipment that is less difficult to handle, that will provide better measurements, such as a pressure gauge that will allow a better air pressure, and also a good thing that could be included in another experiment will be to be also able to change the air pressure so we can get the very most potential of the water bottle while having some results that could be applied to real life things. And well, this principle is actually being used in things such as jet skis, ferries, and other mobility things that are actually more efficient in fuel, and use this principle to innovate in nowadays. And well, we can conclude that yes, water has a direct impact. Nonetheless, it is directly dependent in the air, so there must exist a balance where 450 milliliters was the best, allowing it to get the more distance. And our experiment proved our hypothesis, answered our research question, and used a clear and concise experimental process that allow us to get clear measurements from our results and to draw the best conclusions that we could get from a simple experimentation, but with a clear analysis of results and clear results. Thank you for your attention. This was our key activity.